Good morning, ma'am. This is Parijata. Now I am from third year CSM B section. So I am presenting on correlation and covariance analysis. So when it comes to the introduction to correlation and covariance, these two are powerful statistical tools used to analyze and understand the relationship between the two variables, and we understand how one variable changes with respect to another. These tools are widely used in finance, e-commerce, and research sectors to make the smarter decisions. So when it comes to the understanding covariance, this covariance means it defines the direction of the relationship between the two variables. That is, covariance has types that positive covariance, negative covariance, and zero covariance. Positive covariance means when one variable changes, the other one also changes, or one variable increases, the other one also increases. It is known as the positive covariance. For example, when temperature increases, the ice cream sales also increases. When study hour increases, the marks also increases. It is known as the positive covariance. This is the best example for positive covariance. When it comes to the negative covariance, when one variable increases, the other one decreases. It is known as the negative covariance. For example, when car speed increases, the time decreases. This is the best example for negative covariance. Zero covariance refers to when change in one variable don't affect the other. It is known as the zero covariance. This is about the covariance. When it comes to the next slide, that is calculating covariance. The covariance is calculated by this formula, that is covariance of x comma y equal to summation I equal to 1 to n xi minus x bar into yi minus y bar by n minus 1. Here the xy are the variables and xi is the data point in variable x and x bar is the mean of that variable, that is data points variable mean. In similarly, y also, yi is the data point and y bar is the mean of that data points in variable y, that is n refers to the number of data points in samples. This is the formula for calculating covariance. So when it comes to the correlation, correlation is also similar to covariance, but it goes one step further high. That is, it defines the direction of the relationship between the variables and also defines the strongness of that relationship. So this correlation ranges from -1 to +1. That means when a value near to +1, that correlation is called the strong positive correlation. When a value near to -1, that correlation is called the strong negative correlation. It also takes zero correlation refers to the no relationship between the variables. So calculating of correlations means by using this formula we can calculate the correlation, that is correlation of x comma y equal to covariance of x comma y by standard deviation of x into standard deviation of y. This is the formula for calculating correlation. So when it comes to the differences between the covariance and correlation, the covariance defines the direction of the relationship, but covariance defines the direction of the relationship between the variables. But when it comes to the correlation, it defines the direction and strongness of that relationship between the variables. So whatever the value we obtained in the covariance is not standardized, but in the correlation the value is standardized. Means the covariance takes any values, that positive, negative, even zero also, but the correlation not like that. It has the standardized value. So when it comes to the applications of covariance and correlation, that means it has the wide range of applications in various sectors, in finance and healthcare, like that. In finance, these correlation and covariance are used for portfolio diversification. In regression models, these covariance and correlations are used to understand and identify the redundant variables. It means repeated variables. So when it comes to the healthcare, it is used to identify the heart diseases and lung diseases, means how smoking and lungs diseases are related to each other, and the blood pressure and heart, how both are related to each other. This is about the applications of covariance and correlation. So limitations of covariance and correlations means both have the limitations. So when it comes to the covariance, it is sensitive to scale. That means instead of putting centimeters, if we put the millimeters, it entirely changes the value. So the second one is the first one is sensitive to scale, and the second one is the value is not standardized in this. It takes any values, positive, negative, or even zero also. When it comes to the correlation, it is sensitive to outliers. Even small errors also causes the entire value of the correlation. So when it comes to, it measures only the linear relationship between the variables. The non-linear patterns can be hidden in this. So the practical examples of covariance and correlation is I already mentioned that temperature increases, the ice cream sales also increases. So when speed of the car increases, the time decreases. When study hour increases, the marks also increases. These are the best practical example for covariance and correlation analysis. So this is about the correlation and covariance analysis. So thank you so much for giving this opportunity, ma'am. Thank you.